Mary, Associate Professor in the Department of Computer Science and Engineering. I am going to take the subject operating system. The subject code is 8493. This is the core paper for second year CSC students. So the objective is explore the. I am going to discuss about input-output system in operating system. It explore the structures of objectives, operating system, IO subsystem. Discuss the principles of IO hardware and its complexity. Provides the details of the performance aspects of IO hardware and software. So the outline of my presentation is overview of IO hardware, application IO interface, kernel IO system, transforming IO to hardware. So what is IO management? IO management is a component, it's a major component of operating system. It's an important aspect of computer operation. So IO devices vary greatly, various methods to control them, performance management, new types of devices frequent, supports buses, device drivers connect to various devices, device drivers encapsulate device details, present uniform device access interface to input-output subsystem, IO hardware. So why we are going for input-output devices? It is for storage, for transmitting the data. So you need human intervention. The common concepts are signals from IO devices interface with the computer. Port is a connection point for the device. Bus is a daisy chain or shared direct access. PCA is controlled by peripheral control interface. It's a common for PC and the servers. So expansion IO is a expansion bus connects relatively slower devices. Controller or the host adapter is electronics that operate host bus devices, sometimes integrated, sometimes a separate circuit board. It contain processors, microcode, private memory, bus controller, etc. The typical bus structure will be process control interface, peripheral control interface PCI. You can have the monitor and processor, cache and CSA, single computer system interface. Then SCSA bus will be having the various number of disk, ID, integrated development environment. Then the expansion buses, keyboard and parallel, it will be connected in port. IO hardware. So devices usually have a register where device driver places commands and addresses and data to write or read data from registers after command execution. Data in register, data out register, status register, control register. Typically 1 to 4 bytes or FIFO buffer. So it will be using memory mapped IO devices, data and control command registers mapped to processor address space, especially for large address spaces for which supports graphics. The range is given. Poly for each byte of IO, read BC bit from the status register until 0. Host set read or write bit, and if write copies data into data out register. Host sets command ready bit. Controller sets BC bit, execute transfer. Controller clears BC bit, error bit, command ready bit when transfer done. Step 1 is BC wait cycle to wait for IO from device. So reasonably if device is fast, but inefficient if slow, device is slow. CPU switches to other tasks, but if miss a cycle, data over or lost. Interrupts. Polling we will be having interrupt or interrupt handler. CPU interrupt request line triggered by IO devices. So interrupt handler receives request. It's maybe maskable and non-maskable. So maskable interrupt to ignore the delay, or some are non-maskable. You have to service the so you have to immediately. So interrupt driven IO cycles, a device driver initiates IO. So CPU receiving the request, control transfer to the interrupt controller. It processes the data, returns from the interrupt. CPU resumes processing of the interrupt task. So it is given in the event vector table. The interrupt mechanism are also used in exception. So terminate the process and crash system due to hardware error. The page fault executes when memory access error. System call executes via trap. It's one of the non-maskable interrupt. It's a multiple CPU system can process interrupts concurrently. For operating system designed to handle it, used for time-sensitive processing, frequent and fast. Direct memory access. It requires DM and controller. Then OS writes DMA command block into memory, so it will have source and destination address, read or write mode, count of bytes, write location to the DMA controller. It will be having the master-slave technology. And concept cycle stealing from CPU, but still much more efficient when done. Interrupts to signal completion. Version that is aware of virtual addresses can be even more efficient. 6 steps to process DMA transfer. First, device driver to told to transfer disk data to buffer at address. Device driver tells disk driver controller to transfer C bytes from disk to buffer. Then the disk driver controller initiates DMA transfer. Disk controller sends each byte to DMA transfer. DMA controller transfer bytes to buffer X, increasing memory address and decreasing C until C is equal to 0. When C is equal to 0, DMA interrupts CPU to signal transfer completion. Applications of IO interface. IO system calls encapsulates device behaviors in generic classes. Each IOS has its own IO subsystem and a device driver framework. Devices vary in many directions. It may be a character oriented or stream block oriented, sequential or random, synchronous or asynchronous or both, shareable or dedicated, speed of operation, read only, write only or read. A kernel IO structure. The kernel will be having the kernel IO system subsystem, SCSI driver, single computer system interface, then a keyboard device driver, mouse, PCA, floppy, ATA device will be there. Devices are the hardware associated with devices. Controller associated with each and every devices. Aspect and variation, data transfer mode, character mode or block mode, terminal disk, access method, sequential or random. Say example, modern CD-ROM. Transfer module schedule will be asynchronous. Tape and keyboard, sharing, dedicated, shareable. Tape keyboard, device speed, latency, seek time. Latency is a variation in the delay. Seek time is the time to reach that particular data. So then the time taken for searching the data. Transfer it is the data rate at which the data is transferred. The IO direction, read only, write only and read write. CD-ROM, graphical control disk. Characteristics of IO devices may be block IO, character IO, memory mapped file access, network sockets. So block and character devices, it includes read, write and seek, raw IO and direct IO. You can have DMA. The devices will be using the character devices include keyboard, mouse and serial boards. So the commands will be get and put. Network devices, it uses sockets. The socket is the endpoint of communication. It has pipes, FIFOs, first in first out, steam screws and mailbox, clocks and timer. It has the current time, elapsed time and timer. Programmable interrupt timer is used for timing, periodic control. IOCTL is used for clocks and timers. Non-blocking, asynchronous IO, blocking and non-blocking. Blocking is process suspend until IO is completed. Non-blocking IO call returns as much as available. Asynchronous process runs when IO executes. Two IO methods, synchronous and asynchronous. Waiting process, requesting process, waiting, device driver, interrupt handler, hardware data transfer. Vectored IO, it allows system call to perform multiple IO operation. Unix read EVE, vectored IO, it's a multiple buffer reader. Kernel IO system, it will do the scheduling. Some IO request ordering via per device queue. Some OS try fairness. Some implement quality of service. Buffering, store data in memory while transferring between devices. To cope with the device speed mismatch, to cope with the device transfer size mismatch, to maintain copy semantics. Double buffering, two copies of the data, kernel and the user, varying sizes. Full or being processed, fully processed or being processed. The copy on write can be used for efficiency in such cases. Device status table, keyboard or all the status, whether it's busy or idle, that will be given. So kernel IO system, it has three phases: catching, spooling and device reservation. Catching, faster device holding copy of data, always just a copy. So sometimes combined with buffering. Spooling, so simultaneous peripheral operations online. Devices can serve only one request at a time. Device reservation, printing exclusive access to a device. The system calls for allocation and deallocation. Watch out for deadlock. Error handling, so when an error occurs, how it's going to return. IO protection, user process may accidentally or purposefully attempt to disrupt. So it's defined to be privileged. IO must be performed via system calls. Memory mapped and IO port memory location must be protected. So use of a system call to perform IO. System call, trap to monitor, then perform IO, return to user program. Kernel data structures, so used for IO components, you will be having the track buffers, memory allocation, dirty buffers. It uses vendor processing. Unix IO kernel system, you will have the user process memory, then the kernel memory. User process memory will have the file descriptor. Per process open file table, you have the file system record. then active inode table, then a network information table. So power management, no, not strictly IO, so OS can help manage and improve. The mobile computing has a power management as well as OS concept. So Android develops a complement level IO, and wake clocks, and power collapse, marginal power usage, IO request to hardware operation. So consider reading a file from a disk for an operation, determining device holding file, translate name to device representation. So make data available for to reading requesting process, return to process. So life cycle of an IO request. Thank you. Thanks for. So the possible questions are explain in detail about IO systems. Then how to explain about kernel IO and device driver IO processing, IO request along with the diagram. Thank you.